Okay, here we go for section 2.2, which is word problems and translating. Okay, we're going to start with translating and then go to everyone's favorite word problems. Translating, we did this in our last chapter. The difference is last time we were just translating expressions. So like I gave you 4x plus 3 and asked you to write that verbally. Okay, now we're going to do the same thing but with equations. So now we have equal sign. So we have 4 key phrases here that could replace an equal sign. The word is, all right, or the phrase the same as, the word equals, of course, because we read the equal sign as equals, or is equal to. So any of these expressions could replace an equal sign when it's written algebraically. So let's look at some examples. 7 times a number squared is 5 times the difference of k and m. So a lot of this translating we've done before. What I want you to do is pick out the equal sign. So find the word that represents the equal sign. In this case, they use the word is. Okay, so everything to the left of the word is going to go on the left side of the equal sign. Everything to the right of the word is going to go on the right side of the equal sign. And then we're translating just like we did in chapter 1. So 7 times a number squared, I know that's 7 and then some variable squared. All right, is, so there's my equal sign. 5 times the difference of k and m. The difference of k and m is k minus m. And then it's 5 times that, so I need to put it in parentheses. All right, same thing here. 15 times a number subtracted from 80 is 25. So again, here's my equal sign, the word is. 15 times a number subtracted from 80, so that means 80 minus 15 times a number is 25. Couple more examples. 2 plus the quotient of a number and 8 is the same as 16. So here we go, the same as, there's my equal sign. So on the left side, I have 2 plus the quotient of a number and 8. 2 plus the quotient means division. I'm going to write it as a fraction of a number and 8 equals 16. 27 times k is h squared decreased by 9. There's my equal sign. So 27 times k is just 27k. And then h squared decreased by 9 is h squared minus 9. Now that we can do equal signs, we can translate formulas and equations. So here are some formulas verbally. The area of a triangle equals the product of 1/2 the length of the base and the height. So again, equals, here's my equal sign. So the area of a triangle, I'm going to use A to represent area. Area equals the product of 1/2 the length of the base and the height. So product means multiplying, so I'm multiplying all 3 of these. All right, in a right triangle, the square of the measure of the hypotenuse is equal to, so there's my equal sign. All right, the square of the measure of the hypotenuse C, so the square of C is C squared, is equal to the sum of the squares of the measure of the legs, A and B. All right, sum means I have addition, and it's the sum of the squares, so the square of leg A and the square of leg B. So that's translating just like we did in chapter 1, except now we have equal signs, so we have equations. All right, we're also going to look at something called consecutive integer problems. So the first thing we need is a definition for consecutive integers. And remember, integers are whole numbers, and they're positive and negative. So 1, 2, 3, 4, 5, and then negative 1, 2, 3, 4, 5. Right? And when we say consecutive, it just means that they're in order. So if I have 2, then the next consecutive integer would be 3, and then 4. Or it could be negative. So if I have negative 7, the next consecutive integer would be negative 6, negative 5, so on and so forth. Okay, and then consecutive even integers is of course the same thing, but only even numbers. So if I started at 2, the next consecutive even integer would be 4, and then 6, and so on and so on. Consecutive odd integers, same thing. So 1, then the next one would be 3, then 5. So we're just counting whole numbers in order. And so we can solve problems if we know we have consecutive integers. So find 3 consecutive odd integers with a sum of negative 51. All right, so I know I'm going to have 3 numbers, and I'm going to add them together, and they're going to be equal to negative 51. Okay, I don't know what any of these three numbers are. When I don't know what a number is, I use a variable. Okay, so let's say x. Now, this number is not the same as x, it's something else. But if I just put a different letter, like if I just put y and then z, I have no way to solve that. We can't solve equations that have more than one variable right now. So, what do I have to do? Well, I know that I have consecutive odd integers, which means I have a number here, and this number has to be the next odd number. So let's think about it. Let's just make a list of odd numbers so I can think about this a little bit. Okay, from 1 to 3, didn't I add 2 there? And then from 3 to 5, didn't I add 2? And from 5 to 7, didn't I add 2? So between odd integers, it's plus 2. So if this is my first odd integer, the next consecutive one is going to be x plus 2. All right. Then the next consecutive integer after that would be x plus 4, because I have to add 2 more every time to get the next integer. Now this is an equation that we can solve. All right, I'm going to come down here so I have more room, but I have x plus 2 plus x plus 4, and that is equal to negative 51. We can solve this. Look, I have like terms that I can combine. X plus x, well, that's 3x, all right? And then 2 plus 4 would give me 6. So 3x plus 6 is equal to negative 51, and then I can work backwards to solve. So subtract 6, all right? 3x is equal to negative 57. And then I divide by 3, and x is going to be equal to negative 19, all right? Now, we got x is equal to negative 19, but we got to make sure we answer the question. The question says find the 3 consecutive odd integers. So if my first one is negative 19, the next one would have to be negative 17 and then negative 15. So those are my 3 consecutive odd integers. They're in a row, they're odd numbers. And if we add them up, negative 19 plus negative 17 plus negative 15, I'll get a sum of negative 51. Next example, find the 3 consecutive integers with a sum of 21. So again, I have 3 numbers that I'm going to add together, and they're going to equal 21. Now, this time it's just 3 consecutive integers, 3 numbers in a row, so they don't have to be even, they don't have to be odd, it doesn't matter. Okay, so I have x, the next number, the very next number is just going to be x plus 1. Here I had to add 2 because I was skipping a number, I needed the odd one. I just need the next number, so it's just plus 1, and then plus 2 to get the next one, all right? And so then again, you're going to simplify this and solve. So go ahead and pause here and solve this, and then come back, check your answer. Okay, so I combine like terms, simplify and solve. I got x equals 6, so that's my first number, and then I need consecutive integers, so 6, 7, 8. All right, I want you to pause here, try 3 and 4 on your own, and then come back and check your answer. Okay, so I did it in different colors, so you can see this where it comes down here. So this consecutive integer is negative 30, negative 28, negative 26, and then the 3 brothers are 31, 32, 33 years old. All right, then we're going to look at some word problems. My tips and hints for you on word problems. Break it down, okay? Read the whole thing and then break it down piece by piece. A lot of times you can figure them out in your head, but then you need to be able to take what you're doing in your head and write it out mathematically, and that's where the challenge comes. Okay, so let's look at this problem. Tina went to Costco and became a member. She paid a one-time membership fee of $100 and spent $300 each month on groceries. How much did Tina spend after 1, 3, 6, 9, and a year? Okay, so let's think about this. She paid $100 at the beginning. Okay, that money is spent. Then after the first month, she spent $300. So that means she spent $400 total. This is 1 month. Okay. After 3 months, all right, now she has $100 still. Okay. Then she's going to spend $300, all right, but she's going to do that every month. So she's going to do that 3 times. So I'm going to multiply 3 times 300. All right, so now after 3 months, she has spent $1,000. okay? After 6 months, all right, she still paid the $100 at the beginning, but now 6 times she has gone and spent $300, all right? So that means she has spent $1,900 after 6 months. 9 months, she spends the $100 at the beginning, then 9 times she goes and spends $300. That would be $2,800 after 9 months. And then a year, she spent $100 at the beginning, and then a year means she went 12 times, spent $300. That is $3,700 in 1 year, okay? Write an equation to represent how much Tina would spend given any month M. So here they gave us numbers, fine, 3 months, fine, 6 months. Now we just want to know any month, okay? The math doesn't change. She's still going to spend $100. Then she's going to go and every so many months, she's going to spend $300. Well, we don't know how many months, so we just say M. So now I have M times 300, and I'm just going to rewrite that in the way that we're used to seeing it. So 300M. Second word problem. Samuel has $1,900 in the bank. He wishes to increase his account to a total of $2,500 by depositing $30 per week from his paycheck. Write and solve an equation to find out how many weeks he needs to reach his goal. All right. I want to put a circle around this. How many weeks? That's what we are trying to find. So that is going to be our variable because that's the piece of information that we don't know. So I'm going to use W to represent weeks. Okay, right now he has $1,900, okay, and he's going to deposit $30 every week. So he's going to add $30 every week, and he wants it to be a total of $2,500. All right, so we wrote our equation, and now we need to solve it. Working backwards, I'm going to subtract $1,900 from both sides. 30W equals 600, and then divide by 30. So W equals 20, so it would take him 20 weeks to get up to $2,500. One more example with Miguel's paint cans. I want you to write an equation, solve it, and then we will go over this problem at the beginning of class. That is it for 2.2.